There isn't anything that you need to like jot down or take notes on or anything, just some things I'm trying to show you. And probably as we get into it, you'll be like, oh, okay, yeah, that looks pretty familiar. So sometimes you will have like a grid like this, and it will have a vector arrow where it's saying each square is 1 Newton of force. Thank you, Shelby. And so this would be 1, 2, 3, 4, 5 newtons to the right. I know it's 5 because it was 5 squares, and I know it's to the right because it's pointing to the right. Okay. So like here, those are all. Here they might show 2 arrows where you would need to decide, like, are you combining them because they're going in the same direction, or do you subtract them because they're going in opposite directions? So here they're going in opposite directions. So you go 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5. So 7 minus 5 leaves you with a resultant of 2. Okay, so these are the 2 vector forces, and then it wants to know what force are you left with at the end. And here they're both going in the same direction. So does it make sense to add them or subtract them? Good. So you add 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, and you end up with a resultant of 10 to the right. And I guess I should have said on the last one, okay, don't get funky on me. The larger force is to the left, which is why you end up with the arrow to the left. Okay, so this looks like our one from the notes yesterday. Our force of tension, our force of gravity, and it has the newtons. These are all examples of free body diagrams. So if I said, hey, what is the net force based on this? It would be 400 newtons up, right? If I want the net force on this one, we have force of air resistance, we have force of gravity. Again, I see this arrow is bigger, that arrow is smaller. We're going to get a difference of 200 newtons, and you can either put negative or down, right? Because down is a negative value. So far, so good? All right, now this is where I said we're not going to get forces that change both vertically and horizontally. So what that means is if we have multiple, like we have vertical forces and we have horizontal, but if I look at this, these actually are canceling out, right? Because 50 up and 50 down subtracts to 0. And so then what you're left with is 20 newtons of friction that's all to the left. So we're never going to get one where you have both a vertical component and a horizontal at the same time. So like this wouldn't be a value of something other than 0, okay? When you do that, that's considered 2-dimensional motion, and that gets a little bit more complicated, and so we're going to save that for physics, if you take that with Ms. Sturchy. So again, physical science is just an introduction to things, so this is all we need for our class. So the net force would be 20 newtons to the left, and I know that because those cancel to 0. So it's not like you're combining these. Sometimes people want to add these all up, like you'd end up with 120 or something like that. Just look vertically and take care of that, and then look horizontally and take care of that. And then whatever you're left with is going to be your net force. But don't try to like combine up and side to side. Always look vertically or horizontally, kind of isolated. Okay, so here I see I have normal force, here I have gravity, I have the applied force, and I have friction. So just like what I said, I'm either going to look horizontally first or vertically, and it doesn't matter which one, but you have to pick one of those. So don't go, I'm going to look here and here, right? Or here and here. Look vertically or look horizontally. So as you look at this, what are you going to do with 3 and 3? Add them or subtract them?
Subtract.
Right? Because this one's going up, this one's going down, those are opposite directions, so you subtract them. So your net force vertically is 0. Now let's look at our net force horizontally. 5 newtons to the left, 5 newtons to the right. Yeah, you're going to subtract. So you end up with 0. So this is actually a net force of 0 newtons. And if it's 0, that's the only time you don't have to include a direction, because it doesn't make sense if you're 0. Kind of like how our displacement, we didn't need to include zero, or a direction with that zero. So you have all these forces working on it, and they're all balanced and equal, so you get no change in this object's motion. That's what that means. Okay, so we look over here. So I just always kind of get stuck looking horizontal or vertically first. So I have my normal force, I have gravity, I have friction at work. So I see an up force and a down force. Am I going to add those or subtract them, Brooklyn? Good. So what's 3 minus 3? Good. So I have a 0 vertical force. And then what am I left with? What do you got, Brady?
5 newtons to the right.
5 to the left. Okay. All right. What do we have here? Echo, what do you think? Are these in the same direction, or are those arrows pointing in opposite directions? Okay, so what do we do? Add or subtract them? Good. So what is 20 minus 20?
0.
That's our net force. Okay. Now, this is a little bit different. We actually get a real answer. So, are these going in the same direction or opposite directions? Layla, what do you think? Okay, so what do we do? Okay, so what is 40 minus 25? It is 15. And what direction? Okay, so 15 newtons up. If you had said north, like, that's fine too. Like, if the problem doesn't say, then up or north would both be considered correct. Okay, these ones are a little bit different because it tells you what the net force is. All right, and so then you have to kind of adjust. So those ones we just did were pretty basic. These take it just a little step further. All right, so I have 200 newtons down. I have 50 newtons to the right, and it says I end up with a net force of 0. So I need to decide what happens at location A and location B. Tell me, Layla. Okay, you need whatever to balance. We're trying to get horizontally it to equal 0. So if we fill in a 50, 50 minus 50 is 0. And then we need to get 200 to get to 0, because that's what it said my net force was. So I need to make that what? What do you think, Ethan? What do I need to make B?
200.
Yeah, it needs to be 200 newtons, because 200 newtons minus 200 newtons will give me 0 newtons. So both vertically and horizontally, they need to equal 0. And they do, if we make that 50 and that 200 newtons. Okay, so now it's saying that the net force is going to be 900 newtons up. Andy's like, what? What do you think?
1100.
Okay, how'd you do that?
1100 minus 200 equals 100.
Okay, so if this is your net force up, it means you're going to have a bigger value. You end up with 900 newtons up, right? So if you want to end up with 900 newtons up as your net, you basically, you can think about it kind of logically, or you can ask yourself, like, what do I have to subtract from 200 to equal 900, right? Because this, I would subtract from my 200 to equal this. And so if I make that like a variable, right, to get rid of my 200, I do the inverse or add it. So yes, algebra actually works here. And this would be 1100 newtons. Okay. So here it's saying what we're left with at the end is 60 newtons to the left, right? 60 newtons to the left. So do we have any vertical? No. So how would we get rid of the 300? What do you think, Andy? What can I minus by 300 to end up with 0?
300.
Good. So E is going to be 300. So that takes care of that, right? Now we need to end up with 60 newtons to the left. So we have 80. How are we going to make that happen? If they're going, D is the opposite direction, so we know we're going to have to subtract. So what can we subtract from 80 to get an answer of 60? 20. So if we take 80 minus 20, we will get 60 in the left direction. So basically, you can just kind of ask yourself, what do I have to subtract from 80 to get my 60? And again, you can set it up, or you can just kind of look at it logically and then actually do it. And if you get 60, then you did it right. If you had said 40 and you do 80 minus 40, you're like, oh, well, that's not right because I'm supposed to get 60, right? So you can always kind of plug it in and check too. Okay, one more here. And this one's, I think, kind of awkward. As I look here, we're filling in 3 things. I'm only getting a change that's horizontal. So I can fill in anything for F and H as long as they're the same number. So this could be 1,000,000 and 1,000,000. This could be 1 and 1, right? It could be anything as long as those 2 vertical components are the exact same, right? So then that leaves us horizontally, right? So we need a net force that is going to be 30 newtons to the right. What do you think, Nevaeh? 50? All right, so if I put in 50 minus 20, I end up with 30. So that is correct. And so you can always check yourself. But you can always say, what can I subtract from 20 to equal 30? Okay. And so sometimes these can look a little confusing if we don't go over them. So I just wanted to kind of show you that. I think that, yeah, that was it. In Google Classroom for today, there is, I have these extra links that I posted last night. I forgot that I did not post our unit material stuff yet, so I did that yesterday too. Sorry, I have all those in here now. If you look, there are a bunch of these physics classroom, there's some PhET lab, but there's a bunch of different simulation kind of websites, and we're going to look at a few of them together. But if you want to, like if you're bored, they're kind of like they're kind of fun, like you can make them do all kinds of crazy little things, but it practices the ideas that we've been talking about. So I just have those there for you. Some of you might really like them. Usually there's a couple people in each class that really enjoy them, so I always try to put those on there, and it's good practice.